Let us consider the following application example. Let f of x be equal to x to the fourth minus 8x cubed plus 7. Find the derivative of f with respect to x, and find the equation of the tangent line at x equals 1. F prime of x can be computed by differentiating each term of the given function here. So the derivative of the first term is, copy 4, bring down 4, x to the, and then subtract 1 from the exponent here, third power. Minus, you multiply 8 times 3 times the exponent. So 3 times 8 is 24, minus 24, x to the 3 minus 1, which is 2. And the derivative of a constant is 0. So that's the derivative of the function. Now to find the equation of the tangent line at x equals 1, we would need to compute for the slope of the tangent line at this point. Now the slope of the tangent line is just the value of the derivative of the function at x equals 1. So therefore, m is equal to, evaluate the derivative at x equals 1. So that is 4 times 1 cubed minus 24 times 1 squared. So 4 times 1 cubed is 1, 1 squared is also equal to 1. So that is just 4 minus 24, that gives us negative 20. So the slope is negative 20. Then we use the formula y minus y sub 1 equal to m times x minus x sub 1. This would be our x sub 1. And then to compute for our y sub 1, we will just have to plug in this value of x here to the given function. So that is just f of 1. So f of 1 is equal to 1 to the fourth power is 1 minus 8 times 1 cubed is 8 plus 7. So 1 plus 7 is 8 minus 8 is 0. Our y sub 1 is equal to 0. So we have y minus 0, so that is just y, and our m is negative 20, that's negative 20, times x minus, x sub 1 is 1, minus 1. So this would be our equation, the equation of the tangent line. You can simplify this further by distributing negative 20 to each term inside this parenthesis. You have negative 20x plus 20. So y is equal to negative 20x plus 20 is the equation of the tangent line at x equals 1. Application example. The demand function for a certain product is given by the expression here P equal to 50,000 minus x divided by 25,000. Find the marginal revenue when x is equal to 10,000 units and P is in dollars. Here, we are asked to find the marginal revenue. Marginal revenue is the rate of change of revenue. In other words, we would need to find the expression first for the revenue function before we can find its marginal revenue, its rate of change. Now, the revenue function is computed by multiplying the number of items, or that's the demand function, by the price per item. So therefore, R of x, the revenue function here, is just equal to our demand function, P so that's P of X, times the number of units, which is 10,000 in this case. So times X. So we will plug in X later. So times X. Let's compute first for the revenue function in terms of X. So given P of X equal to 50,000 minus X over 25,000. So we have 50,000 divided by 50,000 minus X divided by 25,000 times X. And this can be simplified as, so if you're multiplying a fraction by a whole number, you can think of this fraction, you can think of the whole number as a fraction 2 with denominator equal to 1. So that means this is just equal to X times 50,000 minus X divided by 25,000. And then distribute X to each term in the numerator. You have 50,000 X minus X squared divided by 25,000. Now the marginal revenue is just the rate of change of revenue, or the derivative of the revenue function. So that's the marginal revenue. Whenever you see the word marginal, that means the derivative. So if we say, if you have marginal cost, that means the derivative of the cost function. Here we have marginal revenue, so it's the derivative of the revenue function. Now using the properties of derivatives, this one is just constant, so we have 1 over 25,000. You can take out the constant. And then just differentiate each term in the numerator. So 50,000 X, the derivative of that is 50,000. So you have 50,000 minus the derivative of X squared is 2X. So minus 2X. And this is our revenue function. Now to find the revenue, when X is 10,000, that means we are going to evaluate the revenue function when X is 10,000. And this is equal to 1 over 25,000 times 50,000 minus 2 times, and then replace X by 10,000. 2 times 10,000 is 20,000. So 50,000 divided by 20,000, 50,000 minus 20,000 is 30,000. So therefore we have 30,000 divided by 25,000. You can then simplify this. 30 over 25 is 6 over 5. Or 1.2. So now the revenue is in dollars, so therefore we say $1.2. So therefore this means that the next unit sold at sales of 10,000 will produce an additional revenue of about $1.20. In other words, selling the 10,001 unit will produce an additional revenue of about $1.20. Next example. The profit in dollars of the sale of X drones can be approximated by this function here. This is your profit function. Find the marginal profit when X is equal to 10 and when X is equal to 15. So marginal profit, that means we need to differentiate our profit function. So the profit function is already given. So let's go ahead and find P prime of X. And then after that, we evaluate the derivative at X equals 10 and then at X equals 15. So to differentiate this, let's just differentiate P of X, or each term of P of X. So let's write this first in exponential form. So 400x is good. Next, we write the second term, 490 square root of x, in exponential form. This can be written as x to the 1/2 minus 600. Then we differentiate now. Okay, so that was just P. And then P prime of x is equal to derivative of 400x, which is 400. And the derivative of 490x squared is 490 times 1/2, or 490 divided by 2 is 245 x to the, then subtract 1/2, subtract 1 from 1/2, that's negative 1/2. And then the derivative of 600 is 0. Therefore, at x equals 10, the marginal profit is given by P prime of 10, and just plug it in to this equation. You have 400 minus 245, and then you have negative 1/2 here. So that means over square root of 10. Then go ahead and plug this into your calculator. Now, using our scientific calculator, we plug in 400. So we have 400 minus 245 divided by the square root of 10. And that is equal to 322.52 cents. So this means we have $322.52. And this would mean that the next unit sold, the 11th unit sold, will produce an additional profit of about $322.52. And so to get the marginal profit at x equals 15, P prime of 15 is equal to 400 minus 245 divided by the square root of 15. Then plugging into your calculator, we have $336.74. So this means, or this implies, that the next unit sold will produce an additional profit of about $336.74.